Welcome to the heart of Rolls-Royce, where engineering meets perfection.
Before a $40 million engine comes to life, everything starts with raw materials. Every alloy is scanned, measured, and verified to meet extreme flight conditions. Heat, precision, and automation pre-in. The preparation phase begins. Inside the vacuum furnace, metals melt into a perfect aerospace blend.
Engineers monitor every variable: cool, temperature, pressure, purity.
Liquid metal travels through a cooling labyrinth to form turbine cores.
At the microscopic level, precision takes shape.
Robots refine what no human hand could perfect.
Every component must meet near-zero tolerance.
From molten alloy to functional geometry, the journey continues.
Every measurement matters at the micron level.
Even airflow simulations begin long before assembly.
The compressor Kotlal, a masterpiece of layered engineering.
Robotic precision guarantees perfect alignment. Carbon composite fan blades define the engine's character. Every blade must be perfectly balanced. Heat-resistant chambers are the engine's fiery core. Materials face extreme pressure before qualification. Only the strongest parts move forward to assembly. Inside the assembly hall, precision becomes teamwork. Compressor stages interlock like a mechanical symphony. Fan blades demand millimeter-perfect alignment. Titanium structures meet carbon elegance. Assembly is a dance of controlled force. Sensors ensure perfection during every connection. The combustion chamber takes its place at the core. Power flows from every carefully crafted stage. Every engine is built with structural harmony.
The engine finally begins to resemble its iconic form.
Before ignition, every fuel line must be flawless.
Sensors track even the smallest vibration. Electrical systems bring intelligence to the machine. Every connection is tested under load. Cooling channels ensure survival under extreme heat. Robots measure geometry with surgical precision.
The engine is prepared for its first rotation.
Rotation tests reveal hidden imperfections.
Thermal expansion is analyzed with infrared imaging.
Every test brings the engine one step closer to flight.
Pressure chambers push the engine to its limits.
Sensors collect thousands of readings per second.
The engine is ready for controlled ignition.
The first flame marks a major milestone. Airflow blasts through the engine core. Vibration mapping ensures absolute stability. Extreme temperature tests simulate real flight conditions. Cooling cycles test endurance under rapid change. Only flawless engines pass certification. With testing complete, assembly enters its final phase. The finishing bay transforms precision into perfection.
Every surface must meet aerodynamic standards.
Protective coatings increase durability and efficiency.
Quality control begins even before final assembly locks.
Precision markings guide future maintenance.
Electronic intelligence is integrated next.
Data cables form the nervous system of the engine.
Final fastening ensures structural integrity. The engine's exterior takes on its iconic form. Soon, this marvel will be ready for certification.
Before certification, every engine undergoes deep structural analysis.
3D scanning reveals imperfections invisible to the human eye.
Internal parts are inspected through volumetric imaging.
Materials must withstand extreme cycles without fatigue.
Cooling behavior is equally important for engine reliability. The engine is then moved to the acoustic testing bay.
Engine sound reveals health and stability.
Noise signatures are mapped with extreme accuracy.
Only engines that meet strict acoustic limits pass this stage.
After acoustic tests, airflow calibration begins. Sensors measure how air behaves at every surface. High-speed cameras capture blade motion in detail.
Blade tip clearance is critical for efficiency. Thermal expansion affects airflow performance.
The engine transitions to endurance testing.
Endurance tests push engines through hours of extreme cycles.
Only engines passing endurance qualify for final assembly lock.
With endurance complete, the engine enters precision alignment.
Even a fraction of a degree can affect performance.
Balancing ensures long-term stability.
Next comes integration with the engine mount system.
These mounts will anchor the engine to the aircraft. Fluid systems connect next Moxabedo, vital for cooling and lubrication. Each line is pressure tested for safety. Electronic systems undergo final verification. Communication interfaces link the engine to the aircrafter's brain. The engine is now ready for certification approval.
Certification teams verify every document and parameter.
Every engine must meet thousands of requirements.
After approval, protective coverings are installed.
The engine transitions into the logistics stage.
Logistics robots coordinate perfectly inside the facility.
Before shipping, engines undergo external inspection. Secure packaging ensures safety in global transport.
Gắn nhãn mã vận chuyển quốc tế.
Forklifts move the crate toward outbound logistics.
From factory to runway, the journey continues.
The engine begins its journey beyond the factory walls. Every movement is tracked for maximum safety.
Transport protocols follow strict global standards.
Upon arrival, logistics teams prepare the next transfer. Heavy lift vehicles take over the operation.
Cargo crews synchronize each movement flawlessly.
The crate approaches the aircraft waiting for installation.
Precision matters, even during loading.
Soon this engine will power global flight.
Its next destination, assembly onto a commercial aircraft.
The engine arrives at its final destination.
Ground crews prepare for unloading. Nhân viên mặt đất chuẩn bị dỡ hàng.
Chuyển kiện động cơ xuống xe nâng hàng.
Specialized transport brings it to the assembly hangar.
Inside, experts await its arrival.
Unpacking reveals the engineering masterpiece.
Aircraft engineers verify compatibility and readiness.
Mounting systems are prepared for installation.
The engine is lifted with millimeter precision. Connection marks the beginning of a new life in the sky. Technicians secure every vital connection.
Digital systems synchronize for the first time.
Hệ thống điện tử máy bay đồng bộ với động cơ.
Before flight, calibration is essential.
Calibration ensures flawless engine response. Fuel systems undergo final verification.
Cooling units activate to simulate real conditions.
The engine prepares for its first on-aircraft startup.
Ignition begins with a controlled spark. The engine roars to life, steady and powerful.
Dữ liệu xác nhận lắp đặt thành công.
With the engine installed, full aircraft systems testing begins.
Control surfaces respond to engine output. Engine exhaust flows are analyzed carefully. Temperature and pressure remain perfectly stable.
Aircraft crews verify cockpit engine interfaces. Taxi testing prepares the aircraft for real runway trials.
Ground crews monitor every sound and vibration.
Runway ready status is finally achieved.
The aircraft moves toward open skies.
Soon, this engine will take its first true flight. Power builds as engineering meets the open sky.
The aircraft lifts, carried by millions of precise details.
The engine now begins its true mission. Back at the factory, pride fills the air.
The engineer welcomes you once more.
This is how a $40 million Rolls-Royce jet engine is born.
Only with precision, passion, and innovation.
Thank you for joining this journey inside Rolls-Royce.
Subscribe for more AI-powered factory tours.